Okay. We'll start the next experiment. See, in the previous session, we have discussed the seventh experiment, design and implement the code converter from binary to gray and gray to binary code using the basic gates, but actually we have done using the XOR gate, not the AND gate, OR gate, or the NOT gate. Now we will discuss the second easiest experiment. After that, the next one is the asynchronous counter using decade counter IC to count up from 0 to n and demonstrate it on a 7-segment display. The IC number is 7447. The specialty about this lab is you have to remember the IC numbers. This is a common question in the Viva. What is the IC number of an AND gate? 7408. IC number of the NOT gate? 7404. What is the IC number of OR gate? 7432. XOR gate? 7486. NAND gate? 7410. 7420 also NAND gate. In that way, the 7-segment display IC is 7447. See, first we'll understand the problem statement. In the class, whether they have discussed this counter, can anyone reply? Whether they have started that chapter called counters, which is there in the 5th module. ಯಾರಾದರೂ ರಿಪ್ಲೈ ಮಾಡ್ತೀರಾ ಕೌಂಟರ್ಸ್ ಮಾಡಿದಾರಾ ಅಂತ? ಅದನ್ನು ನಾವೇ ಮತ್ತೆ ಪಾಯಿಂಟ್ ಔಟ್ ಮಾಡಿ ಕೇಳಬೇಕು. ದೀಕ್ಷಾ AH, ಆರ್ ಯು ದೇರ್? ದೀಕ್ಷಾ AH ಇದ್ದೀರಾ? ಇಲ್ವಾ? ಜಾಯಿನ್ ಮಾಡಿ ಎಲ್ಲ ಹೋಗಿದಾರಾ? ಶ್ರೀಲಕ್ಷ್ಮಿ?
Yes, sir.
Whether they have discussed this decade counters chapter, whether they have started?
No, sir.
What is the meaning of no? Whether they have not, or you don't know whether these counters
Sir,
will
I
come?
have not attended 3 to 4 classes of AD.
Why?
ಊರಿಂದ ಆಚೆ ಹೋಗಿದ್ದೆ, ಔಟ್ ಆಫ್ ಸ್ಟೇಷನ್ ಇದ್ದೆ ಸರ್.
Out of station idra? Okay. In which module they are discussing now?
ಫಸ್ಟ್ module, sir.
Module 1, sir.
ಯಾವುದು?
ಫಸ್ಟ್ module.
ಓಕೆ, ಫಸ್ಟ್ ಮಾಡೆಲ್ ಮಾಡ್ತೀರಾ? 5th ಕೌಂಟರ್ಸ್ ಚಾಪ್ಟರ್ ಇದೆಯಲ್ಲ?
Yes, sir. It's complete, sir.
It's completed. ಓಕೆ, ಕಂಪ್ಲೀಟೆಡ್ ಆಗಿದೆ ಅಂದ್ಮೇಲೆ ಅಲ್ಲಿಗೆ ಕೌಂಟರ್ಸ್ ಅನ್ನು ಹೆಸರು ಕೇಳಿರ್ತೀರ ಅಲ್ಲಿಗೆ, ರೈಟ್? ಐಶ್ವರ್ಯ, ಐ ಥಿಂಕ್ ಯು ಹ್ಯಾವ್ ವರ್ಡ್ ದಿಸ್ ವರ್ಡ್ counters many times. Whether it has been understood or not, I don't know. I think you have heard this word called counters. See, the counter is nothing but a circuit. Counter is nothing but a circuit which gives one input based on the clock inputs. I think you have heard the word clock inputs. The clock input is nothing but you can visualize like this. In the input on the trainer kit, if you press the switch on, the light will glow. When you switch off that input there, the LED will switch off. But whenever I give the power supply, based on the time when it is going to switch on and off automatically, then you can call that as a clock. For 1 second, if that LED glows once and it is going to turn off, on and off. In 1 second, if you see that case, one on and off, then that clock you can call it as 1 hertz. In 1 second, if it going to switch from on to off 10 times, that LED is going to glow and off, on, off 10 times in 1 second. Then that clock is going to call it as a 10 hertz. 100 hertz clock means 100 times it is going to changes its state from on to off in 1 second. That is the meaning of clock. If I give the clock, that clock input, we are going to give it to the circuit. Based on that clock input itself, what is then what is the difference between a clock input and a normal input? That is the next question. A clock input and a normal input. Can anyone say what is the difference between a clock input and a normal input? Can anyone reply? Once again, I'll ask Aishwarya itself because he is going to respond. Aishwarya? Aishwarya? The doubt is which Aishwarya? There are two Aishwaryas, I think. Right? Aishwarya BH and Aishwarya P. Aishwarya P? Aishwarya P?
Yes, sir.
Ah. There are two types of inputs. One is the normal input, another one is clock input. Have you seen the trainer kit in the physics lab? ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದ್ದೀರಾ ಐಸಿನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ದೀರಾ ಟ್ರೈನರ್ ಕಿಟ್ ಮೇಲೆ, ಆಮೇಲೆ ಅದನ್ನ ಆಪರೇಟ್ ಮಾಡಿದ್ದೀರಾ ಫಿಸಿಕ್ಸ್ ಲ್ಯಾಬ್ ಅಲ್ಲಿ? ಮಾಡಿದ್ದೇನಾರು ನೆನಪಿದೆಯಾ ಆ ಥರ? ಹ್ಮ್ ಮಾಡಿರ್ಬೋದು ಅಂತೀರಾ? ಯಾರಿಗಾರು ಮಾಡಿರೋರಿಗೆ ನೆನಪಿದೆಯಾ? See, there will be a power supply for the trainer kit. Trainer kit is nothing but it's a ಮೆಕ್ಯಾನಿಕಲ್ ಡಿವೈಸ್ ವೇರ್ ಯು ಪರ್ಫಾರ್ಮ್ ಆಲ್ ದಿಸ್ ಆಪರೇಷನ್ಸ್. ಐಸಿ ಪ್ಲೇಸ್ ಮಾಡಿ ಕನೆಕ್ಷನ್ಸ್ ಎಲ್ಲ ಕನೆಕ್ಟ್ ಮಾಡ್ತಿರಲ್ಲ, ಅದಕ್ಕೆ ಟ್ರೈನರ್ ಕಿಟ್ ಅಂತ ಅನ್ನೋದು. There will be a power supply. For IC, if you want to give an input, manually you have to press the switch. Then only the input will going to pass to that circuit. ಆ IC ಪಾಸ್ ಆಗಬೇಕು ಅಂದ್ರೆ ನೀವು ಸ್ವಿಚ್ ಆನ್ ಮಾಡಬೇಕು. ಆ ಸ್ವಿಚ್ ಆನ್ ಮಾಡಿದ್ರೆ +5 volts ಆ ಐಸಿಗೆ ಹೋಗುತ್ತೆ. ಆಫ್ ಮಾಡಿದ್ರೆ 0 volts. Instead of that, that is called as a normal input. Instead of that, clock input ಅಂತ ಅಂದ್ರೆ ನೀವು ಜಸ್ಟ್ ಪವರ್ ಸಪ್ಲೈ ಆ ಟ್ರೈನರ್ ಕಿಟ್ಟಿಗೆ ಇರುತ್ತೆ. ಫಾರ್ 1 second ಇನ್ಪುಟ್ 5 volts ಹೋಗುತ್ತೆ, ತಕ್ಷಣ ಸ್ವಿಚ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಆಫ್ 0 volts. ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಮತ್ತೆ 5 volts ಹೋಗುತ್ತೆ, ತಕ್ಷಣ ಆಫ್ ಆಗುತ್ತೆ. Means it is going to change its state. Then that type of input is called as clock input. You don't going to manually press the switches on and off. ಅದೇ ಡಿಫ್ರೆನ್ಸ್ ನಾರ್ಮಲ್ ಇನ್ಪುಟ್ಗೂ ಕ್ಲಾಕ್ ಇನ್ಪುಟ್ಗೂ. ಕ್ಲಾಕ್ ಇನ್ಪುಟ್ ವಿಲ್ ವರ್ಕ್ ಬೇಸ್ಡ್ ಆನ್ ದಿ ಹರ್ಟ್ಸ್. ಅದು ಯಾವ ಹರ್ಟ್ಸ್ ಇನ್ ತಗೊಂಡಿದ್ದೀರಾ ಅಂತ. 10 hertz ಇನ್ ತಗೊಂಡ್ರೆ 1 second ಅಲ್ಲಿ 10 ಸಲ ಹೋಗಿ ಬರುತ್ತೆ. 100 hertz ಇನ್ ತಗೊಂಡ್ರೆ 100 times ಆನ್ ಅಂಡ್ ಆಫ್ ಚೇಂಜ್ ಆಗುತ್ತೆ ಸ್ಟೇಟ್. 5 volts 0 volts, 5 volts 0 volts. In our normal eye, you cannot visualize, you cannot find out the difference of this 10 hertz or 100 hertz or anything. You can only identify 1 hertz clock. In 1 second, if there is a changes its state from 0 to 1, that you can identify. ಅದು ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದೇ ಕ್ಲಾಕ್ ಅನ್ನು ನೀವು ವಿಜುವಲೈಸ್ ಮಾಡೋಕ್ಕೆ ಆಗಲ್ಲ. ನೀವು ಅದನ್ನು ಎಲ್ ಇ ಡಿ ಕನೆಕ್ಟ್ ಮಾಡ್ಬಿಟ್ಟು ಔಟ್ಪುಟ್ ನೋಡಿದ್ರೆ ಯಾವಾಗ್ಲೂ ಗ್ಲೋ ಆಗ್ತಾನೆ ಇರುತ್ತೆ, ಅದು ಆಫ್ ಆಗಿರೋದು ಕಾಣಿಸೋದೇ ಇಲ್ಲ. ಯು ಕೆನಾಟ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್. That is a difference. Now I think you have understood the meaning of the word clock input. Now this IC is going to work based on the clock input, not on the normal input. See, this counter is a circuit okay, I should go to the manual. See, the manual which I have shared is the old one, but you have to see the number of experiments which is there, the manual of the last scheme, but now they have reduced. See the experiments which are there in the syllabus copy and then you write. Don't write whatever is there, everything in the lab manual. See, and you can see the name also, it is 17 CSL 37. Now it is 18 CSL. Okay. Now, asynchronous counter using decode count IC. See, what we are doing here is, once there will be a two ICs. There will be a two ICs. One IC will give one output. That output will be received by the second IC, and that second IC will show the output on the 7-segment display. 7-segment display means where you see the 7-segment display in the traffics, what you see in the signals, those numbers, that is the 7-segment display. Account ಅಲ್ಲಿ ನೋಡ್ತಿರಲ್ಲ 7-segment display 21, 20, 19 ಆ ಟೈಮಿಂಗ್ಸ್ ಅಲ್ಲಿ ಏನ್ ನೋಡ್ತಿರಲ್ಲ ಅದು 7-segment display. ಅದ್ರ ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ ಕೌಂಟರ್ IC ಇರುತ್ತೆ. For this experiment, what is the application if I ask? You can say directly in the traffic signals, there will be a 7-segment display, right? There, they use this decode counter IC. What is the meaning of this decade? Decade is 10. From 10 values, you are going to see on the 7-segment display. 10 values are 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All those values you are going to see. Whether it is a binary output, no. Decimal output. Decimal output, if you want to see, then you require 7-segment display. You can see the 7-segment display. This is what the 7-segment display. How many displays are there? 7 are there. For A, B, C, D, E, F, G. If I want the digital watches, you have seen, right? The digital watches. There also there will be a 7-segment display. If I want to display one, B and C, if they are on, it is enough. If I want 8, all the segments should on. If I want 5, it should display A, F, G, C, D. If it wants to display 7, A, B, C is enough. In that way, it is going to work. That output you have to show. That here the input for this circuit is, there is no input. When you switch on the trainer kit, if all the connection is done properly, I will directly see the 7-segment display and I will see the numbers from 0 to 9. Once again reset. It will come once again to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In that way, you will see the output. There is no manual input. Then how these ICs will drive? Because of the clock input. Since there is a clock input, 1 hertz clock input, that clock input is going to drive this IC. ಇಲ್ಲಿ ಮ್ಯಾನ್ಯಲಿ ಏನು ಇನ್ಪುಟ್ ಕೊಡಲ್ಲ. ನಾನು ಎಲ್ಲ ಕನೆಕ್ಷನ್ಸ್ 2 IC ಕನೆಕ್ಷನ್ಸ್ ಎಲ್ಲ ಮಾಡಿ ಟ್ರೈನರ್ ಕಿಟ್ ಆನ್ ಮಾಡಿದ್ರೆ ಸಾಕು. ಎಲ್ಲ ಕನೆಕ್ಷನ್ಸ್ ಪ್ರಾಪರ್ ಇದ್ರೆ 7 ಸೆಗ್ಮೆಂಟ್ ಡಿಸ್ಪ್ಲೇ ಮೇಲೆ ನಂಬರ್ಸ್ ನೋಡೋದಷ್ಟೇ. 0 1 2 3 4 5 6 7 8 9 ಬರಬೇಕು, ಮತ್ತೆ ರೀಸೆಟ್ ಆಗಬೇಕು. 0 1 2 3 4 5 6 7 8 9. ನೀವು ಎಷ್ಟು ಹರ್ಟ್ಸ್ ಇನ್ ಕ್ಲಾಕ್ ತಗೊಂಡಿರ್ತೀರೋ ಅಷ್ಟು ಫಾಸ್ಟ್ ಬರುತ್ತೆ. 1 ಹರ್ಟ್ಸ್ ಇನ್ ಕ್ಲಾಕ್ ತಗೊಂಡ್ರೆ 1 ಸೆಕೆಂಡಿಗೆ 0 ಬರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡಿಗೆ 1 2 3 4 5 6 7 9 ಸೆಕೆಂಡ್ಸ್ ಬೇಕು 9 ಬರೋ ತನಕ. ನೆಕ್ಸ್ಟ್ ಒನ್ಸ್ ಅಗೇನ್ ರೀಸೆಟ್ ಆಗುತ್ತೆ. ನೌ ದ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಈಸ್ why 2 ICs? Now the input and output is clear. What is the input? Clock input is there. Since that clock input is handled in the connection itself, there is no manual input. ಮತ್ತೊಂದ್ಸಲ ಏನು ಕನೆಕ್ಷನ್ಸ್ ಮಧ್ಯದಲ್ಲಿ ಕೊಡೋದೇನಿಲ್ಲ. What is the output? Directly we'll see the output on the 7 segment display. What output? 0 1 2 3 4 5 6 7 8 9. Okay. Then the next question is why 2 ICs? The 2 ICs are, in order to connect to the 7 segment display, in order to drive this 7 segment display, 1 IC. ಈ 7 ಸೆಗ್ಮೆಂಟ್ ಡಿಸ್ಪ್ಲೇ ಅಲ್ಲಿ 7ಗೆ ABC ಆನ್ ಆಗಬೇಕು, 8ಗೆ ಎಲ್ಲದೂ ಆನ್ ಆಗಬೇಕು, 2ಗೆ ಸಮ್ ಆಫ್ ದಿ ಡಿಸ್ಪ್ಲೇಸ್ ಮಾತ್ರ ಆನ್ ಆಗಬೇಕು ಅನ್ನೋದು ಯಾವ್ದಕ್ಕೆ ಗೊತ್ತಿದೆ? ಈ IC ಗೊತ್ತಿದೆ, 7447. 7447 is an 7 segment display IC. Remember the number 7447. It is an 7 segment display IC. ಈಗ ಇನ್ನೊಂದು IC ಇಲ್ಲಿದೆ 7490. ಹಂಗಾರೆ ಇದೇನಿದು? This 7490 is, it generates binary output. What binary output? 0 to 9. In order to represent 0 to 9, how many bits are required? 4 bits. Therefore, the output from this IC, the output from the 7490 IC is 4 bits. 4 bits are the output. ಯಾವ್ದದು? QA, QB, QC and QD. ಅದರಲ್ಲಿ MSB ಯಾವುದು? QD. QA ಯಾವುದು? LSB. What is this IC is doing? 7490. 7490 is doing just giving the binary output. What is the minimum value? 0. Then 1, 2, 3, 4, 5. Binary output it is going to give 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0. In that way, binary output it is going to give. Then what is the role of this 7447? This 7447, it is going to receive that 4 bits binary and particular 7 segment display it is going to on. ಅಷ್ಟೇ. ಅದೇನ್ ಬೈನರಿ ಇನ್ಪುಟ್ ಕೊಡುತ್ತಲ್ಲ ABCD, ಅದನ್ನು ರಿಸೀವ್ ಮಾಡುತ್ತೆ, ಈ 7 ಸೆಗ್ಮೆಂಟ್ ಡಿಸ್ಪ್ಲೇ ಮೇಲೆ ಔಟ್ಪುಟ್ ನೋಡ್ತದೆ. That is what it is going to do. As simple as that. In order to drive the 7 segment display 7447, in order to generate the binary output 7490. How this actually it is going to work? It is going to work based on this clock input. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲೊಂದು ಕ್ಲಾಕ್ ಇನ್ಪುಟ್ ಅಂತ ಇದೆ. ಟ್ರೈನರ್ ಕಿಟ್ ಮೇಲೆ ನಾರ್ಮಲ್ ಇನ್ಪುಟ್ ಪ್ರಕಾರನೇ ಕ್ಲಾಕ್ ಇನ್ಪುಟ್ ಅಂತ ಒಂದು ಸಪರೇಟ್ ಪಿನ್ ಇರುತ್ತೆ, ಅಲ್ಲಿ 1 ಹರ್ಟ್ಸ್ ಇಂದು ಅಲ್ಲಿಂದ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು. ಯಾವ ಪಿನ್ ನಂಬರ್ಗೆ? 14th ಪಿನ್ನಿಗೆ. ಯಾವ ಪಿನ್ನಿಗೆ? 14th ಪಿನ್ನಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು. I think this much of basics is clear about 7490 and 7447. ಇದಕ್ಕೆ ಯಾಕೆ ಡಿಕೇಡ್ ಕೌಂಟರ್ ಅಂತ ಕರೀತಾರೆ? 7490 ICಗೆ ಯಾಕೆ ಡಿಕೇಡ್ ಕೌಂಟರ್ ಅಂತ ಕರೀತಾರೆ? Can anyone reply why it is called decade counter? Because it generates 10 values 0 to 9. That is why it is called as decade counter. Whether it is an up counter or a down counter, can anyone reply? whether it is called a up counter or a down counter. 7490, it's an up counter because 0, after that the output it is going to give is 1, after that 2, 3, 4, 5, it is going to increase, not decrease. That is why it is up counter. There are ICs, I think in the fifth your module when they have discussed all these things: up counter, down counter, up bar, down counter, all those things. The next question is after 0 to 9. After 0 to 9, how actually 9 will change it to 0? How it is going to change it to 0 is there are reset pins are there. R1, R2, R3, R4. These R1, R2 pins, what they do is, after it reaches the highest value in the up counter, what will be the highest value? 9. After 9, it should be reset to 0. That will be indicated by this R1 and R2. Means the second pin and third pin, if you connect it to the ground, it indicates, this indicates it has to be reset to the 0. That truth table, it is also there. See here, if R1 and R2 is set to high and L3, R3 and R4, there will be 4 reset pins. There will be 4 reset pins. R1, R2, R3, R4. They are pairs. If R1 and R2, if they are connected to high input means 5 volts. Low input means 0 volts. Or you can call it as a ground pin. If R1 and R2, if they are connected to the high pins, after 9, it will be reset to 0. It is not going to worry about R3 and R4. R3, R4 ಏನು ಬೇಕಾದ್ರೂ ಆಗಿರಲಿ, R1 and R2ನ ನೀವು 5 volts ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ 9 ಆದ ತಕ್ಷಣ ಔಟ್ಪುಟ್ ಬರೋದು 0. In the same way, R3, R4, if they are connected to high and it is not going to worry about R1 and R2. Whatever it can be, low and high or high and low. If this is the case, after 9, it will be reset to 9. Means in down counter, we use this concept. After 0, it should be going to the 9. Maximum value set ಆಗುತ್ತೆ. Minimum value set ಆಗಬೇಕು ಅಂದ್ರೆ R1 and R2 ನ ನೀವು high connect ಮಾಡಬೇಕು. By default, we are going to connect it to here ground.
Hello, Mukesh.
What is the doubt? Doubt ಬಂತ ಅನ್ಸುತ್ತೆ. In the IC, see how much it is going to understood by seeing this diagram. Only that much I am going to explain. In detail, I don't explain this because it will just be it is not going to understood. That is why only the basics part, how much you can understand, that much only I like to explain. Be careful about, try to understand this. What about this QA, QB, QC, QD? Oh, those 4 pins, they are the output pins. If you see NC like this, NC, that NC means inside the IC itself, they have not connected. That is why it is the meaning is no connection. Even if you on the trainer kit, you should not connect it. What about this A and B? This A and B are clock inputs. They are clock inputs. Means from the trainer kit, you have to connect this to the clock input. And they are reset pins. And there will be a ground and VCC pin, 5th and 10th pin. Without this, your IC will not going to work itself. If all the connections are there, everything is proper, 100%, the connections is 100% correct. But without connecting the ground and VCC, the circuit will not be complete and the IC, it is not going to work. VCC and ground. Always you should remember this VCC and ground. Now I think it is clear. The circuit connections of this. See here A, B, C, D, E, F, G means there will be a 7 pins on the trainer kit for 7 segment display. Those pins you have to connect it to that. Those pins you are going to connect it to that. Don't worry about these 3 pins. The lamp test or ripple blanking input, ripple blanking output. Don't worry about that. All those 3 pins by default they are going to be connected to VCC. Now I think it is clear what is the meaning, what is the use of this IC and what is the use of this IC. Do you have any doubts in this? Please try to ask. If you ask the doubts, then we'll explain in detail. We'll go to the another level of explanation. ಏನಾರ doubt ಕೇಳಿ. How many ICs are required for this experiment? 2. As simple as that. Wow, how many number of pins? 7490 decade counter IC, 14 pin IC. In the Viva, we'll ask like this. What is the how many number of pins for 7447? Is the 16 pin IC. 7447. Which are the ground pin and VCC pin? 8 and 16. 7490. Which are the ground and VCC pin? 5 and 10. Which are the reset pins of 7490? 2 and 3, 6 and 7. In that way, you should remember the pin numbers. The first IC 7490 will generate the binary output. 7447, it will receive that binary output and it will give you the decimal output. That decimal output you are going to see it on the 7-segment display. Do you have any doubts in this? And in the experiment, see, in the syllabus copy, if you see, they have said from n less than or equal to 9. N less than or equal to 9 meaning it is not always from 0 to 9 it has to count. We can stop in between from 0 to 5. After that 5, it should reset to 0. 0, 1, 2, 3, 4, 5. That small changes that you can do it in the circuit itself. With the small reset pins are there. You are going to use the advantage of that reset pins. What those reset pins will do? It is going to reset to 0. When actually it has to reset to 0? After 9 it has to reset to 0 means no extra connections you should do. After some number 5, it has to reset to 0. Then you have to properly use the reset pins R1 and R2. You have to properly use the reset pins R1 and R2. One small example I'll show how to design for any other number from 0 to 9. Instead of that, from 0 to 9, I want to connect from 0 to 5. See, designing mod 5 counter. Mod 5 counter meaning it should count from 0 to 4. 7-segment display ಅಲ್ಲಿ 0 ಬರಬೇಕು, 1 ಬರಬೇಕು, 2 ಬರಬೇಕು, 3 ಬರಬೇಕು, 4 ಬರಬೇಕು, 5 ಬರಬಾರ್ದು. ನೆಕ್ಸ್ಟ್ ಬರಬೇಕಾದ್ರೆ 0. ಯಾಕೆಂದ್ರೆ ನೀವು ಡಿಸೈನ್ ಮಾಡ್ತಿರೋದು mod 5 ಕೌಂಟರ್. If I say mod 8 counter means 0 to 7 ಬರಬೇಕು, ನೆಕ್ಸ್ಟ್ ತಕ್ಷಣ 0 ಆಗಬೇಕು. In that way you have to design. For that, if you design this for from 0 to 9, a small changes if you do, it is going to work for other mods. Mod 5 ಗೆ ಏನು ಮಾಡಬೇಕು, ಆ ಟೇಬಲ್ ಬರ್ಕೊಬೇಕು ನೀವು. ಇಲ್ಲೊಂದು ಟೇಬಲ್ ಇದೆ, mod 5 QC and QA pin. These are the output pins. These are the output pins of the first one, 7490. Those pins, you have to connect it to R1 and R2. Why you have to connect only these two? Why not QB and QD? That is the question. ಇವೆರಡನ್ನ ತಗೊಂಡೋಗಿ R1 and R2 ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? 0 ಬರುತ್ತೆ, 1 ಬರುತ್ತೆ, 2 ಬರುತ್ತೆ, 3 ಬರುತ್ತೆ, 4 ಬರುತ್ತೆ. ತಕ್ಷಣ 5 ಬರೋ ಜಾಗಕ್ಕೆ 0 ಬಂದ್ಬಿಡುತ್ತೆ. Why it is going to happen like that is, when it is 5 means binary representation is 0 1 0 1 0 1 0 1. Is it clear? Then will for 0 1 0 1 we'll give the names for that: QD, QC, QB, QA. Which are ones in that? QA and QC. That is why QC and QA we have selected. Binary representation ಅಲ್ಲಿ 5 represent ಮಾಡಿದ್ರೆ 0 1 0 1 ಬರುತ್ತೆ. A B C D ತಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ QA ಮತ್ತೆ QC ಮಾತ್ರ 1 1 ಇರುತ್ತೆ. When both are 1 1, if you connect them to R1 and R2, if you connect them to R1 and R2, when the high input enters the R1 and R2, what will happen? ನಾನು ಆಗ್ಲೇ ಒಂದು ಟೇಬಲ್ ತೋರಿಸ್ತೆ. ಹೈ ಇನ್ಪುಟ್ ಬಂದಾಗ ಏನಾಗುತ್ತೆ? R1 and R2 ಗೆ it is going to reset to 0. That is what we are doing. That's all. 2 extra connections we are going to do. Mod 5 ಬೇಕು ಅಂದ್ರೆ QC ಮತ್ತೆ QA ಇಂದ 2 ವೈರ್ ತಗೊಂಡ್ಬಂದು R1 and R2 ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ 4 ಡಿಸ್ಪ್ಲೇ ಆಗುತ್ತೆ. ಇನ್ನೇನು 5 ಡಿಸ್ಪ್ಲೇ ಆಗಬೇಕು. 1 1 ಬರುತ್ತೆ QA QC. ಆ 1 1 ಡೈರೆಕ್ಟ್ ಆಗಿ R1 and R2 ಎಂಟ್ರಿ ಆಗುತ್ತೆ. R1 and R2 ಎಂಟ್ರಿ ಆಗಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? 5 ಡಿಸ್ಪ್ಲೇ ಆಗೋ ಜಾಗಕ್ಕೆ 0 ಡಿಸ್ಪ್ಲೇ ಬರುತ್ತೆ. ಆ ರೀಸೆಟ್ ಪಿನ್ಸ್ ನ ಯೂಸ್ ಮಾಡ್ಕೊಂತೀವಿ ನಾವು ಅಷ್ಟೇ. We are going to use the advantage of the reset pins. Mod 4 ಡಿಸೈನ್ ಮಾಡ್ತಿದ್ವಿ. Mod 4 ಡಿಸೈನ್ ಮಾಡ್ತಿದ್ವಿ ಅಂದ್ರೆ 4 ಬರಬಾರ್ದು. 4 ಬರಬಾರ್ದು ಅಂದ್ರೆ ಏನಾಗಬೇಕು? 0 1 0 0. ದಟ್ ಇಸ್ ದ ಬೈನರಿ ರೆಪ್ರೆಸೆಂಟೇಷನ್. ಅಂದ್ರೆ QC ಪಿನ್ ತಗೊಂಡೋಗಿ 2 ಪಿನ್ ಅಲ್ಲೇ 2 ಕನೆಕ್ಷನ್ ತಗೊಂಡ್ಬಂದು R1 and R2 ಕೊಟ್ರೆ 0 ಬರುತ್ತೆ, 1 ಬರುತ್ತೆ, 2 ಬರುತ್ತೆ, 3 ಬರುತ್ತೆ, 4 ಬರಲ್ಲ. ನೆಕ್ಸ್ಟ್ ತಕ್ಷಣ 0 ಆಗುತ್ತೆ. In that way, you can design for any mods. Mod 2 counter, Mod 3 counter, Mod 4 counter, Mod 5 counter, Mod 6. 0 to 9 automatic ಬರುತ್ತೆ. ಬೇರೆ ಯಾವ್ದಾರ ಮಾಡಿಗೆ ಡಿಸೈನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ Mod 8, Mod 7, Mod 6, Mod 5. Mod 9 meaning 0 to 8 it has to display. Mod 2 means 0 and 1 it has to display. In that way, we have given already the figure. See here. From QC for mod 4 counter, QC ಇಂದ ಏನ್ ಮಾಡಿದೀವಿ? ಒಂದು ಕನೆಕ್ಷನ್ R1 and R2 ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ. ಅವ ಡೈರೆಕ್ಟ್ ಆಗಿ ನೀವು ಟ್ರೈನರ್ ಕಿಟ್ ಆನ್ ಮಾಡಿದ್ರೆ 0 1 2 3 0 1 2 3 0 1 2 3 mod 4 ಅಂದ್ರೆ ಹಂಗೆ. That is how it works. This you can understand here 70 to 80%. Finally, if you see it on the trainer kit only, clearly you are going to understand. When you see the hardware 7490 decade counter IC, 7447 7 segment display IC, 7408 AND gate, 10 NAND gate. I think this is clear. Asynchronous counter. See why the name asynchronous here is, see, in order to generate 4 output QA, QB, QC, QD, there will be 4 flip-flops inside that. There will be a 4 flip-flops inside 7490. Those 4 flip-flops, they are not going to change their output at the same time. 4 flip-flops, they are not going to change their output at the same time. That is why it is called as asynchronous. If they change their output at the same time, one clock input ಕೊಟ್ಟಿದ ತಕ್ಷಣ 4 flip-flop output change ಆಯ್ತು ಅಂದ್ರೆ 0 ಇದ್ದದ್ದು 1 ಆಯ್ತು, 1 ಇದ್ದು 0 ಆಯ್ತು ಅಂದ್ರೆ change ಆಯ್ತು ಅಂದ್ರೆ then it is called as synchronous counter. Here, if you open the 7490 and if you check, it is there will be four flip-flops, and those four flip-flops, they are not going to changes their output at the same time when there is a clock input. That is why it is called as asynchronous counter. ಇದು ಒಂದು ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ, ಯಾಕೆ ಇದಕ್ಕೆ ಅಸಿಂಕ್ರೋನಸ್ ಕೌಂಟರ್? ಪ್ರೀವಿಯಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ಇರೋ ಅದಕ್ಕೆ ಸಿಂಕ್ರೋನಸ್ ಕೌಂಟರ್ ಅಂತ ಯಾಕೆ ಕರೀತಾರೆ ಅಂದ್ರೆ, ಆಲ್ ದ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ಸ್ ಇನ್ಸೈಡ್ ದಿ ಐ ಸಿ, ದೇ ಆರ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಚೇಂಜಸ್ ದೇರ್ ಔಟ್ಪುಟ್ ಅಟ್ ದ ಸೇಮ್ ಟೈಮ್. ಸೇಮ್ ಟೈಮ್ ಅಂದ್ರೆ ಒಂದು ಕ್ಲಾಕ್ ಇನ್ಪುಟ್ ಕೊಟ್ಟಿದ ತಕ್ಷಣ ನಾಲ್ಕು ಚೇಂಜ್ ಆಗಲ್ಲ, ಎರಡು ಚೇಂಜ್ ಆಗುತ್ತೆ, ಎರಡು ಚೇಂಜ್ ಆಗುತ್ತೆ. In that way it is going to work. In the next lab we'll discuss synchronous counter and JK flip-flops. Okay, if you have any doubts you can ask at any time through the WhatsApp. In the group you can ask. If you have any doubts, still I have 2 minutes time, you can ask. Do you have any doubts in this? Please complete writing the record including this experiment. 4 experiments in the digital part you have to write, 3 in the analog. Any day in the next week I'll ask you to send the snapshot of your record. I think if you don't have any doubts, then you can exit. Thank you.